x-axis should be time, right? So first one heating, then holding, then cooling, right? So when you are heating the metal to a specific temperature, your structure of the steel will be, or a structure of the steel is converted to the austenite structure. So in this position, austenite structure formed, right? So then you are keeping that metal for a specific time period by to uniformly form that austenite structure. So here also austenite structure. Now what you are doing in the third phase, you are cooling down the temperature of that metal. So properties or the structure will be changed because in this stage it is in the liquid form or a molten metal, right? So you are cooling down. Cooling down means solidification starts. So in this time, in this phase, another structure forms. That means this austenite structure converted into another structure. That is the structure changes during the hardening process. So what will happen? During the hardening process, austenite structure is converted to the martensite structure. What is that? Right? This is the structure changes. Austenite converted into the martensite. Right? Okay. So what you are doing during the cooling process, because during cooling process is different in the heat treatment processes. According to the heat treatment, different types of heat treatment process, cooling process is different. So in this case, hardening process, in this third step, that means cooling process, what will happen? That means you are having heated metal here. So that heated metal is cooled rapidly, right? Not slowly. So it is cooled rapidly. That's important point. Second point, where you are doing this cooling process, you are doing the cooling process in water or the oil or the molten salt bath, right? Water bath or the oil bath or the molten salt bath, right? So this cooling process is done in this water bath, oil bath or the molten salt bath. So you are doing rapid cooling here. So due to this rapid cooling, austenitis changes to the martensite. That is the reason of formation of this martensite. Why? You are doing rapid cooling process. So and that rapid cooling process is done in this medium, water or the oil or the salt bath medium. Therefore, this structure changes happen, right? Other thing, where you can use this oil bath or where you can use so the water bath, that mean in so that mean which kind of metals can be used this hardening process using oil bath medium or a water bath medium. That means if we are using alloy steel for the hardening process, then cooling process should be done in the oil bath medium, right? So that means if you are using alloy steel, right? So then you need to have oil bath medium for the cooling process. In other way, if you are using plain carbon steel for the hardening process, you need to have water bath medium for the cooling process, right? So as usual, what's the reason for doing this hardening process? Common purpose of this heat treatment process is to change the properties, right? So increase the hardness or wear resistance, right? Or a surface life of this steel. You need to do this hardening process. Okay, other step, other important thing, martensite structure. You are doing the hardening process, then austenite structure changes to the martensite. What is the structure? The structure of this hardened material should be a, if you see the cross-sectional image of the steel, you can see like this kind of shape, needle like shapes, right? You can see here, this one also needle like shape, this one also needle like shape, but these both are different. Why? In here this cooling process is done by water bath medium, here cooling process is done by oil bath medium. According to the cooling medium, internal structure will be changed, right? So using hardening process you can get needle like internal structure or fibrous mass, right? So this is called as hardening process. If you have any doubt. Okay, so to harden the material you are doing the hardening process, but there's a disadvantages of this process. What's that? This hardened material, so once you have done this hardening process, hardened material is a hard and brittle. That material is hard material and then you can get the brittle material. So you cannot use this kind of material in engineering applications, right? So in order to make it suitable for your engineering materials, your brittleness of this material needs to be reduced, right? Understood? Because this hardened material is a hard material and then brittle material. So you cannot use for your engineering application because it's a brittle material. So in order to make it suitable for your engineering applications, definitely brittleness needs to be reduced. Therefore, what you need to do, tempering process is carried out. Right? So if you are doing the tempering process, definitely hardening process should be done before that, right? So hardening process followed by for this tempering process, right? And this, yes, so this oil bath medium, water bath medium, molten salt bath medium, you can, so these three kind of medium are used for your hardening, that means cooling process. Oil bath medium can be used only for the alloy steel hardening processes. If you are using water bath, or if you need to use water bath medium, definitely you have to have plain carbon steel for the hardening process. If that means if you are using plain carbon steel for the hardening process, then cooling medium should be water bath, right? Okay, then we'll continue. So TT curve, once we finish the tempering process, we'll discuss about the TT T, that means triple T curve, right? Okay, there's a, so that means this hardening process has main two types or the two varieties, right? One thing is edge hardening, other one is case hardening, right? These are major hardening varieties. Edge hardening, other one haze hardening. So see, what is edge hardening? So it can be named as precipitation hardening also. So what is edge or the precipitation hardening? Normally, this edge hardening mostly done for the non-ferrous metal, right? That is important point. So as usual, you are having three steps, right? First one, heating, holding, cooling, right? Edge hardening also has these three steps. So if you want to use edge hardening, then definitely you should have non-ferrous metal for this process. So non-ferrous alloys, right? So this alloy is heated to an intermediate temperature, right? So this is the temperature. So you are heating that alloy to an intermediate temperature. Then held it for a specific time period, right? So you are keeping that metal at that temperature point for a specific time period. So you are holding that metal, right? In that time, precipitation of any metals occurred, right? Because non-ferrous alloys, you are using non-ferrous alloys for the heating. So in here, definitely you are having molten alloy or a mixing solid plus liquid form of that alloys, right? So you are keeping that form for a specific time period. So in that time period, what is happening is precipitation takes place, right? Since it is required to keep for a long time period, it is known as age gardening. Why it is named as age gardening? You are keeping for a specific time period, precipitation occurs. So since precipitation is occurs, it is called as precipitation hardening. And since it's required to keep for a long time period, it is called as age gardening, right? That's why you named this process as a age gardening or the precipitation gardening, right? Next one, that is edge gardening. Next one is case gardening. Case gardening means normally if you are doing any heat treatment process, in most of the cases, all metal is used for your hardening process. Maybe outside layer, inside core. But in this particular case gardening, what's happening is, so see, you are having this cube shape of your metal. Then you are doing the case gardening to the metal, right? Case gardening means this hardening occurred only the surface of the metal, right? You are not doing the heat treatment process inside the metal. Only you are doing the heat treatment process to the surface, outer layer of the metal. That is why it is called as case gardening, right? So according to the procedure variation, you can further classify that case gardening into harburizing, nitriding, cyaniding, induction gardening, flame gardening. These all are types of case gardening, right? Important thing, you are doing only the that means you are doing the heat treatment process only for the surface of your particular metal, right? And according to the procedure changes, that means how you are doing the case gardening, according to that way you can further classify that case gardening into this type, right? See here, first one, harburizing. So what are you doing in that process? You are adding the carbon. So carbon is one element, right? You are adding carbon element to the particular metal. That means to the surface of the metal, right? So if you are adding carbon to that particular surface of that metal, that process is called as harburizing, right? Other important thing, how you can add the carbon to the particular steel or a particular metal, surface of the metal. How you can add? That is the procedure. That means you have to heat the metal. That means in this case steel, right? You have to heat the steel in the atmosphere condition. Atmosphere condition means in your surrounding environment with carbonaceous gas or the carbon containing any solids, right? You have to heat the metal with this kind of carbonaceous gas or the carbon contained solid. You have to heat that steel with this, then only you can add the carbon element to the surface of the metal, right? But in the case of nitriding, same as carburizing, nitriding means you are adding the nitrogen to the surface of that metal. How you can add the nitrogen? Same process. You have to heat the steel in the atmosphere condition with ammonia gas or the mixture of molten cyanide salt. In the cyanide salt means in the cyanide it has to have carbon and nitrogen. So definitely you can add nitrogen to the surface of the metal, right? But in the case of cyaniding, you have to add carbon and nitrogen to the surface of the metal. So what you need to do, you have to heat that metal, this alloy steel, in a molten bath solution of this cyanide and other salt. Right? So that's the procedure. If you heat the steel in the molten bath solution, then definitely you can add the carbon and nitrogen to the alloy steel, surface of the alloy steel. So that is called as cyanide. So in these three process, commonly same. That means you are adding any element to the surface of the metal. So in this case carbon, this case nitrogen, this case carbon and nitrogen. Okay, that's mean carburizing, nitriding, cyaniding, right? But there are other two types of haze hardening process available. In these two types, you are not adding any element to the surface, right? What you are doing is, see here, induction hardening. Induction hardening means definitely you have to have induction coils. So see, as a sample, you are having induction coil like this. Induction coil should be a copper medium, copper induction coil, right? Then you have to insert your metal, particular metal, where you have to do this case hardening process, right? So you have to insert this metal in the copper induction coil. Then you have to heat the coil. Then the surface of this metal will be hardened. But how you are doing this heat to the coils? You have to give the current in electricity current, right? Frequency, high frequency electric current you have to apply to the coil. Then that is called as induction hardening. But in other case, flame hardening. Flame hardening means you can easily understand, definitely there should be a flame, right? For in here, all are surface is heated, but you have to use oxyl acetylene torch, right, for the flame. That means, so see, where you can see this oxyl acetylene torch, normally for the welding processes, right? So you have to use that torch, oxyl acetylene torch, to produce the flame, and then using that flame you have to heat that particular surface of that metal. Then you have to do the cooling process for all the cases, right? So these are called as case hardening. So do you have any doubt? Do you have any doubts regarding case hardening and the types of case hardening and the edge hardening? Yeah, what is the temperature for edge hardening? So it should be like see here. See here. So this is the normalizing and annealing process temperature range because we need to get the molten metal, that means austenite structure for the this heat treatment process. If you want to get the austenite structure, then definitely you have to heat the metal to that specific temperature, right? But in the case of a hardening process, what you need to do is you have to heat the metal to a high temperature, not it should be higher than lower and upper critical temperature, right? Then you are keeping for a time period and then you are cooling down that metal according to the cooling rate, and the where you are cooling down is the main thing for the edge and case hardening process. So if you just think about, if you are doing a edge hardening process, then that's the case hardening process. If you are doing edge hardening process, intermediate temperature means, that's what I have mentioned here. Intermediate temperature mean definitely it should be a like this. This is lower critical temperature, this is upper critical temperature. Definitely it should be higher than that, right? Then according to the non-ferrous metal alloy you are using, that temperature range will be changed. But common thing, all the temperature should be higher than this, right? Then this temperature range will be different according to the non-ferrous metal alloy, right? This is the temperature range for this hardening process. There are specific cooling media separately for two methods, edge hardening and the cooling hardening. Here, see here, in the case of case hardening process, if you are doing this flame hardening, then you have to use water medium. Water medium mean in the way of spraying. You have to use water spray for the cooling process, right? Other things, that is special case because you are giving the flame, right? That's why you have to use this water spray. Other thing, other induction hardening or other precipitation hardening, other harborizing cases, you can use oil bath medium, you can use water bath medium, molten salt bath medium. Then according to your metal, what are the metals you are using for your case hardening, that will be changed, right? So those things you don't need, but for the common thing you need to know what are the mediums you can use for your thing, because For other heat treatment process, you need to have air medium, but in this case you cannot use air medium for your hardening process. Those things you need to have. Right, so this is the difference in between full and case hardening. Here you can do the full hardening process, full heat treatment process. Here you cannot do that one. You have to use the hardening process only for the surface. Likewise, these are the different types. Other final heat treatment process is tempering process. Right, so definitely this tempering process followed by hardening process. Right, so why you need, as I discussed earlier, why you need this tempering process? Because hardened material is brittle material, so therefore you need to reduce the brittleness of that metal, so therefore you need to have this tempering process according to your engineering application purposes. So this tempering process followed by hardening process, right? So temperature time curve. This is temperature, this is time curve. So you have to have the hardening process, then again tempering process, right? This is the some temperature range here. Heating the metal, holding the metal, quenching or the cooling the metal. So this is hardening process. Now in this tempering process, what you need to do is you have to heat that particular cooled steel or the quenched steel again. Right, once you cool down the hardened metal again, as soon as cooled, you have to heat again. Then you have to keep it and then you have to cool down here. What is this temperature line? This temperature line is, you don't need this temperature line, is called as eutectoid temperature line, right? So in this, so you have to heat this second time, you have to heat the metal below this temperature line. So you are cooling down, then again you have to heat the metal. So this is tempering process, right? So that means you had austenite structure here, then here once you finish your hardening process, you have hard and brittle material here. So again you are doing the tempering process. So once you finish this tempering process, the structure of that steel is tempered martensite. Once you do this tempering process, structure changes is austenite structure into tempered martensite. Right? But it is not a perlite. You have to remind it, it is not a perlite. It is a tempered martensite structure. That means hardness and brittleness is reduced. Right? So other important thing, how much hardness is reduced is depend on the temperature and time. Right? So according to the temperature and time, The how much hardness is reduced is depends, right? Do you have any doubt about this? Okay, so again you can classify this tempering process into this low temperature tempering, medium and high temperature. So you can easily identify. So what this means? Low temperature tempering, that means the heating temperature. If that heating temperature is low range, that is called as low. If that range is in between the medium range, that is medium temperature tempering. If that temperature range is in the high range, then that is called as high temperature tempering, right? So there are main two special type of tempering available, right? One thing is Oss tempering, other one is Marr tempering, right? So Oss tempering means, what's the difference in between Oss tempering and Marr tempering? See here, temperature time curve. What are you doing? You are heating the metal, shocking the metal, then cooling the metal to a specific temperature, then you are holding in that temperature, then again you are cooling down, right? So this line should be at room temperature. That means your cooling temperature should be above the room temperature. That's the important thing, right? You are quenching or the cooling down, then you are keeping, and then again you are cooling down, right? So what you are doing, you are quenching or cooling from the austenite temperature rapidly to avoid the formation of ferrite and pearlite. Right? So you are doing the cooling process rapidly, right, in the Oss tempering process. But in the Marr tempering process, you are doing the cooling process from the austenite temperature in a hot fluid. Hot fluid means it can be hot oil or it can be molten salt, right? So that is called as Marr tempering. In the case of Oss tempering, you have to keep that metal for a specific time period, but that temperature should be higher than the room temperature, right? And in the Oss tempering cases, cooling rate should be a moderate rate, right, in the both cases. So if you compare the drawing, see, this thick line is a Oss tempering curve, second line is a Marr tempering curve. That means cooling rate of this Marr tempering is higher than Oss tempering process, right? What's the structure changes in this Oss tempering? Austenite structure from here, austenite structure changes to the bainite structure. But in the second case, austenite structure changes to that mean it during this process, this mart tempering produces tempered martensite. Right? These are the two different special types of tempering process, os and mart. But the different is cooling rate and cooling medium, and then how you are doing this special quenching process and the structure changes. These are the 5 things you need to remind it, right? So this is os tempering and mar tempering. Other thing, we missed TTT curve. This is your homework. Temperature time transformation curve, right? You have to draw for the all heat treatment process: hardening process, annealing process, normalizing process, os tempering, and mar tempering, right? Consider these 5 heat treatment process and draw this temperature time curve. As an example, just if you are drawing one process like this, maybe one process can be like this, other one process can be like this, according to the cooling rate is changed. So compare these 5 heat treatment process. In the next class, you have to explain me, right? So this is heat treatment process. If you have any doubt, then we can move to the casting process. If you have any doubt, so this is another type of manufacturing process, metal casting. That means casting process, right? What is casting process? One thing, it is a manufacturing process, right? As you all know, it is a one kind of manufacturing process. And other thing, first, what are the basic requirement you have to have when you are doing casting process, or that you have to consider, right? One thing, if you need to do the casting process, you have to have mold, right? Other thing, you have to have liquid form of your metal, that means molten metal. Okay, so if you need to have a molten metal, then definitely you have to know the melting process of the metal. Then only you can have the liquid form of the metal, right? Then you need to know the solid solidification process, right? Then you need to know the how you can remove the mold to take that solid part of the design. That means casted component, right? Then how you can remove the mold, and then once you removed it, you have to do the fine touch up, right, to the metal. So that process, cleaning, finishing, inspections, right? So these all basic requirements you have to have, or you have to consider when you are doing the casting process. So if I ask you to write about what is casting process, you have to write, okay, it is a manufacturing process. It involves, right? What? Then, what are they? You have to write the basic requirement of your hosting. Then, that is a definition of hosting process. That's the easy way of writing hosting process. You don't need to by heart this sentence. You have to remind the basic requirement of your hosting process, and then you have to write it as a manufacturing process. Okay. It basically has, so it basically involves, then write the requirements including comma, right? Okay, definitely you should have the molds for your casting product. So there are mainly two types of molds available. One is expandable mold, other one is permanent mold, right? What do you mean by expandable mold? Expandable mold means you can use only one time. That means single use mold. That means when you are removing the casting metal, what you need to do is you have to break the mold, and then you can take the casted metal. So that means you have to break the mold. So that means next time you cannot use that particular mold for your purposes, right? Then again you have to make the mold, and then you have to do it for your purpose. So that is called as single use molds. So that means expandable mold. Second type of mold is permanent mold. Permanent mold means it has some joints or screws or the locks. So when you need to remove the casted metal or the casted component, you have to easily eject the mold, and then you can take it down, and then again same mold you can use it for your different purpose. So that is permanent mold, right? Another type of mold available, composite mold. Composite mold means it is made of composites, right? So main two types of mold is expandable mold and permanent mold. So normally permanent mold made of metals, but in the case single use mold or the expandable mold made of sand or a plaster, ceramics, right? It's mainly ductile materials, right? So you are destroying when you are removing the solidified metal, right? Then you need to have the second requirement is you need to have the liquid form of your metal, because then only you can pour that liquid form to your mold. So then you need to consider the melting process, melting method, right? As we discussed in the previous class, how you can melt the metal, you have to do the heating process. So for this process, you can have different types of furnace. So there are different types of furnace available. They are the cupola furnace or the crucible furnace, like the induction furnace. In the case of induction furnace, definitely this furnace has induction coils. Right, in electric arc mean you are using the electric for your heating, ignite process, right? So just see here, this is a crucible furnace. This is outer sketch of this crucible furnace. This is inside cross-sectional image of this crucible furnace. See here inside there's a round shape drum available. So you have to put your metal inside this drum, and then there's a place here you have to give the heat or the ignite this furnace through this way, then heat is passed along this way, and then excess heat can be removed from this way, right? Then important thing is non-ferrous metal only can be heated or melted using this crucible furnace. You can use this crucible furnace only for the non-ferrous metal, right? Other thing, energy efficiency is very low. It can be 7 to 20%, very low. But in the case of cupola furnace, you can see this is the sketch of cupola furnace. When you compare this cupola furnace with previous crucible furnace, you can use this furnace for the melting of cast iron, right? But when you compare the efficiency is higher than crucible furnace because it's around 50%, right? But when you are heating this casting iron, you have to add limestone, coke, and other some parts like flux, coke with your metal, right? Then you have to add them inside this drum, and then you have to ignite the coke, right? Then it will heat it to the upside. That means it is called as up to this place charging door. Then you can get the liquid form of the metal using this tap. Right? One thing you need is one main difference of cupola and crucible furnace. What are the items you can melt using this furnace? What's the energy efficiency comparison, right? Then you have melted your metal, so you have liquid form of the metal. Then you need to pour that molten metal to your molten cavity. So when you are pouring the molten metal, you need to consider the two things. Pouring rate should be considered. So you have to control your pouring rate. Then when you are pouring your molten metal to the cavity, sometimes air bubbles trapped inside the mold cavity. So you have to make sure your air or the gas bubbles traps inside the cavity to escape, right? Otherwise you cannot get your desired shape of your casted component, right? So these two things you have to consider when you are pouring the molten metal. That means you have to consider the pouring rate. Other one, gas or the air bubble should be escaped from the cavity, right? Then you have to keep that mold for a specific time period because you are doing the solidification process, right? Then once you finish your solidification process, you have to remove the mold. So according to your mold type, if you are using expandable mold, you have to break the mold and you have to take the casted component. Or if you are using permanent mold, you have to eject using the locks or the screws, and then you can take your casted item from the mold. Then final touch up. So you can do your final touch up using grinding or the polishing, brushing. Likewise, using this finishing operation, you can do this final touch up. That means you are doing the cleaning process of your casted part, and then once you finish your final touch up, you have to inspect that product whether that quality is okay or not, right? So these are the main steps you have to consider when you are doing the casting process. Okay, you finish your casting process. Sometimes you will get the defects. According to the shape of defects, it can be named as blow, scar, blister, and the misrun, call shut, likewise cap, and these are the washes, right? See, these are the shapes. If you get a casted component like with this gap shape, it is called a scar. If you get like this excess amount is attached to it, it is called as wash, right? There may be question. Name the type of casting defects. So you have to write these names. For the we can give or like this image and the name the defects given here. So you have to name the picture. Or we can ask you to list down 2 type or 3 type of casting defect with cleaning sketch. Clean sketch, right? Then you have to draw this one and then you have to name it, right? Then advantages and limitation. So definitely casting defects is high, so therefore final accuracy is low, so poor surface finished. But you can do any complex shapes using this method, or you can produce any large or the heavy component, right? Because low cost. If you consider the sand casting process, the single mold using sand mold, then low cost, right? That's a comparison, right? Up to now, if you have any doubt. Yes, if there is casting defect, then what we do for that is it destroy or make it again. It's up to your defects. See here, if it's like a wash kind of defects, you can do the finishing touch up. You can remove that excess part from your uh, part. Oh, if it is a misrun, then definitely you have to do it again. If it is this blister, scar, and blow, definitely you have to do it again. See here, you cannot use this product for your purpose, right? Definitely you have to do it again. If the wash kind of defects, then you can try to remove that excess part. Understood? Any questions? Okay, so we'll stop at this moment. So in the next class, we'll discuss about the sand casting process and the die casting process, right? There are 2 types of die casting process, so we'll discuss that in the next class, right? If you have any doubt about hardening process, tempering process, this casting process, you can ask now itself. Or just other thing, you can go through the lecture note today. If you have any doubt, correct the doubt and then contact me through the LMS or the mail, right? So then today itself I'll upload this recorded session to the LMS, so you can go through it. Then you can, if you have doubts, then you can contact. Why we need expendable molds? Because it is always need to break. No, sometimes for the low cost purposes. See, if you are doing sand casting, sometimes you need, but you have your budget is less, right? So, but you need to produce a higher, large quantity of your part, right? So in that cases, you can use this kind of molds, because other one permanent molds mean definitely you have to make the permanent mold using metals. So mold mean it should have the different shapes according to your desired shape. So then according to your shape, then definitely you have to make different variety of molds using the metals. Then your cost will be high. In the case of sand, then low cost. But definitely both have advantages and disadvantages. Okay, any question? Okay, then if you, since you don't have any questions, then we can wind up this session at this time, since you have other lectures at 10, right? So I'll wind up this session now, then we'll continue it to the next week, right? Okay, shall I wind up this meeting? Okay, so I'll wind up and stay safe. Okay.